Good morning. Today we're going to be watching the 1.2 first half lecture. This is on fractions in algebra. Okay, now fractions in algebra. 2/3 is a fraction, which indicates part of a whole. Note the top number 2 is the numerator and the bottom number 3 is the denominator. Again, this is language. This is vocabulary. So when I refer to the numerator, I'm meaning the number on top. Denominator, the one on the bottom. If the numerator is larger than the denominator, it's called an improper fraction. Okay, improper fraction. For example, 12/7 is improper. Why is it improper? It's improper because it's greater than 1. It should be written as 1 5/7. That's proper. So improper means that it's actually a fraction greater than 1. All right, mixed number has a whole number and a fraction. So the 1 and the 5/7 would be a mixed number because it has a whole number and a fraction, so it's mixed. All right, converting a mixed number into an improper fraction. Multiply the denominator of the fraction and the whole number. Then add the numerator to the results. That sounds very complicated. In practicality, it's actually pretty easy. Place the results from step 1 over the denominator of the original mixed number. All that is saying, oops, I'm still highlighting. There we go. Okay, so all that is saying is I take 3 times the 5, so I multiply those two, and I'm going to add the existing numerator. And then I place the whole thing over the original denominator. So 3 times 5 is 15. So now I have 17/5. Okay, 5 times 7. Multiply those two. 5 times 7 is 35. I add the existing 1, and I put the whole thing over the original denominator, which is 7. So I end up with 36/7, an improper fraction. Okay, now these I want you to do. So get out your pencils. You should have your paper already copied, and go for it. Okay, so 6 times 3 is 18. 18 plus 1 is 19. So this should have been 19/3. Do the next one. You can do it. 10 times 3 plus 2. Okay, so that's 30 plus 2 all over the original. 32/3. All right, converting an improper fraction into a mixed number. Now going the other way, it's a little more difficult. Okay, you divide the numerator by the denominator and express the remainder as a fraction by writing the remainder over the divisor. Lots of vocabulary in there, makes it look really hard, but it's not. My favorite way to do that is to rewrite the top as a multiple of the denominator so that I can see it, right? So here I can see that it is 1 2/3. All right, here, 17/4. Well, I know 16 is a multiple of 4. So 16/4 is 4 1/4. Okay, so now I want you to do it. I'll give you some time. What's the closest multiple of 2? All even numbers are multiples of 2 to 13. That is less than 13. Okay, So you end up with that plus 1 over 2. So 12 over 2 is, half of 12 is 6, plus 1/2. So it should be 6 1/2. 5 over 4. There's only one 4 inside of a 5. So it's going to be 1 1/4. Now you're getting the hang of it. Not too bad. All right, factors and prime factors. Factors are any two numbers that are multiplied together. So factors of 20. Well, 5 times 4. That would be those would be factors. 2 times 10. Those would be factors. And actually, 20 times 1. So you really have 3 sets of factors, 3 possible ways of getting a 20. Prime numbers only have 2 factors, one in themselves. Only have 2. So 20 is definitely not prime. Obviously, it has 3 sets of factors, not just 1 set. List some prime numbers. So 3, 5, 7, not 9. All even numbers or factors are not prime because they have 2 as a factor. So we're looking only at odd numbers. 3, 5, 7 are prime, but 9, the next one is actually 3 times 3. So 9 is not in it. But 11 is, and 13. 15 is 3 times 5. 17. 19. And then 21, 3 times 7. So that's not prime. 23, prime. 25, 5 times 5. 27, 3 times 9. 29. Okay, so you get the idea. Composite numbers are numbers greater than 1 that are not prime. So any number not on this list and less than 30 is composite. It's got more than one set of factors. Prime factorization are prime numbers that multiply together to give you back a given number. So if I took 20, I can factor that into 5 and 4. 5 is prime, but 4 is not. 4 is 2 and 2, which are prime because there's no factors for 2 except 2 and 1. So the prime factorization for 20 would be 5 times 2 times 2. That would give me 20. All right, to find the prime factorization, you do a factor tree. That's what you just saw me do. All righty. So prime factor 90. Well, let's see. $90 is 9 times 10. Those are the obvious. 9 is 3 times 3, and 10 is 2 times 5. So my prime factors are going to be 3, 3, 2, and 5, because those are all prime. 12, 2 and 6, 2 is prime. 6 is 2 and 3. So my prime factorization for 12 is 2 times 6 times, oops, no 6, apologies, that's not prime, no 6. That's, alrighty. Okay, so it's 2 times 2 times 3. Basically, it's the ends of all your trees, your branches. Okay, so I want you to do 75 and 18. Go ahead, you can do this. Come on. Do 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 do. Okay, 75. Well, if you don't see that it's divisible by 25, you can see that it's divisible by 5 just because it ends in a 5. If it ends in a 0 or a 5, it's divisible by 5. So divide that by 5 and you get 15. Okay, now personally, I would see this as 3 times 25, and that's 5 times 5. So those are my factors. And 18 would be 2 times 3 times 3, because it's 2 times 9. Okay. I'm sorry, I keep shifting my screen so I can write, and then I kind of slide out of the picture. Okay, simplifying fractions to lowest terms. Write the prime factorization of each number, and each numerator, and each denominator, and divide out common factors. Okay, so we're going to do a prime factorization of 12. You can see we already did that up here. So we have 2 times 2, that is a funny looking 2, times 3, over prime factorization of 32 is 2 times 2 times, it's actually 5 2's. All right, so I can cross off those, and I am left with 3 over 8. Okay, now for 2, 6 is merely 2 times 3. 15 is 3 times 5. But notice I can get rid of the 2 3's, and I'm left with 2 over 5 as my final answer. So now you go ahead and do 18 over 21 and 15 over 25. Notice you up above, you did 18 already. Okay, and when we did 75, we had to do 25. So you should be able to do these just fine. I know. Do do do. You guys are getting hooked to this. Do 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 do. Yeah, okay. I'm not quitting my day job. Don't worry about it. All right, so 18 over 21 is going to give me 3 times 3 times 2. 21 is 3 times 7. So I end up with 6 over 7. 15 over 25, they both have 5s. That's going to leave me with 3 over 5. Okay, not so bad. We're getting there. Multiplying fractions. Multiply the numerators and the denominators. Simplify if possible. Okay, so for fractions, you're just multiplying straight across, right? So 2 times 5 is 10. 3 times 7 is 21. Nothing was able to cross out. Now here, I'm going to be sneaky and notice that 12 is 2 times 6. So now I have 11 over 2 times 7. So it's simplified and made my multiplication easier. Now this next one is mixed numbers. So I'm going to switch them into improper fractions. Okay, 3 times 3 is 9 plus 1. So I have 10 over 3 times 2 times 4 is 8. 8 plus 3 is 11 over 4. Well, 10 is 2 times 5. 4 is 2 times 2. So now I can cross out the 2's, and I end up with 5 times 11 over 3 times 2. All right, I want you to do the next 3. All right, here we go. You can always mute it if you need to. Do 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 do. Okay, I know it's getting old. All right, 2 times 3 and 5 times 5, again straight across. 6 over 25, nothing simplified. 10 times 3, notice I can get rid of the 5 because this is 2 times 5, 6 over 11. Mixed numbers, we're going to convert them first. 1 times 5 is 5 plus 4 is 9. 2 times 3 is 6 plus 2 is 8. All right, remember 9 is 3 times 3. So I can cross out 2 of the 3's. So one of the 3's on top. 3 times 8 is 24. And I'm just left with the 5 below. There we go. Not too bad. All right. This is our last part. Dividing fractions. Multiply the first fraction by the reciprocal of the second. Okay. Fancy words. It's really flip and multiply. So I look at this and I say, oh, this is actually that. All right, 6 is 2 times 3. So I can cross out the 3. I'm left with 2 times 2, which is 4 over 1. I can, whoa, that was bad. I can drop the 1, and I have 4. The second one. Okay, now remember, I have a 1 down there. So when I flip and multiply, I get 5 over 6 times 1 over 3. Well, nothing's going to simplify, so I've got 5 over 18. And this last one we have to convert to mixed numbers. 3 times 8 is 24, plus 3 is 27. You've got to know your times tables. This is going to be very important. Times. Now, 2 times 4 is 8, plus 1 is 9. But this is now I have to flip it. So that is now my denominator. And the 4 is now my numerator. Well, 27 is 3 times 9. So I can cross off the 9. And 8 is 2 times 4. So I can cross off the 4's. So I'm left with 3 over 2. All right, so now I want you to do the next ones. I will wait. Okay, enough doo-doos. I know I did that quietly. It's for those of you who are getting annoyed at me. All right, 7 over 8 divided by 3 over 4. So I have 7 over 8 times 4 over 3. Well, the 4 goes into 8 twice. So I end up with 2 still on top times 7 over 2 times 3, which is 6. All right, yay. Common, this is mixed number. We have to convert it. 5 times 8 is 40 plus 3 over the original 8. Flip and multiply. 2 times 4 is 8 plus 1 is 9. And the denominator is now that 4. All right. All right, the 4 goes into the 8 twice. I have 43. 2 times 9 is 18. All right.